Hello everyone and welcome to my video on factoring quadratic special cases difference of two squares. I'll also be doing perfect square trinomials, but that will be a different video. So if you're looking for that, check out that other video. Alright, so difference of two squares. This is quadratics that fall into that specific pattern. They are literally a difference, so that means subtraction of two squares. So a perfect square minus a perfect square, right? And that's going to be factored into the square root of those perfect squares, one binomial where we're adding them, and one binomial where we are subtracting them. All right, so when you see two perfect squares being subtracted by each other, that could be a quadratic. That's a difference of two squares. You take the square root of each of those terms and make one binomial where you're adding them and one binomial where you are subtracting them. So let me just make some examples here and you can see what I'm talking about. So x squared minus 36. Now this has to be a difference of two squares, so it has to be subtraction. If it's an addition problem or adding, that cannot be factored using real numbers. So x squared minus 36. In order to recognize one of these, you can see the quadratic is missing its middle term, that bx term. It just has the square term and the constant term. So that's something that jumps out at you to recognize one of these. Also, another thing you're looking for is the fact that it's a subtraction problem. And then the first term and the last term need to be perfect squares, right? So in this case, x squared is a perfect square. Really, any variable to an even power is a perfect square, so that's something you can look out for. And we should all recognize 36 as a perfect square. So what you're going to do in a problem like this is you are going to first just find the square root of the first and last term. So here we have x squared. So the square root of x squared would just be x. And if you want to find the square root of a variable, you could just divide the exponent by 2. 2 divided by 2 is 1. We don't need to write the 1. Right, and then I want to find the square root of the 36. You're not really worried about the sign in the middle because you just use that to check that it was a minus. Once it's a minus, we know it falls into this pattern and we don't have to worry about doing anything else with it. And you should know the square root of 36 is 6. All right, so then what we're going to do is we're going to create our two binomials, one with a plus, one with a minus, and you're going to put those two terms into it. So we'll start with that square root of the first term, square root of x squared, which was x. That's going to be the first term of both binomials. And then the square root of the second term, which was 6, goes in as the second in each binomial. And there you go. We have it. All right, so let's take a look at another example. Let's make this one 9x squared and minus, and let's say 144. Okay. All right, so we are going to take the difference of two squares here. Now, you'll notice that there's actually a GCF here. I know what you're thinking. You're saying, oh, well, it is a minus, and, 9's a perfect square, x squared is a perfect square, 144 is a perfect square. Yes, that is true, but there's also a GCF here. We can actually factor out a 9 before we do the difference of two squares. Right? So, like, let's say I didn't know that, and I just went through, and I said, all right, I see the perfect squares. Let me take the square root of the first term and the square root of the second term. Right, and you get the square root of 9x squared is 3x, the square root of 144 as 12, and then you're going to get your two terms, 1 plus, 1 minus, right? And that first term, the square root of 9x squared, 3x, goes in the front of both, and make this one a plus again, and the square root of 144, which is 12, goes in the other one. Now, you should be able to recognize that there was a GCF here because one or more of the binomials have a GCF in it itself. Right? You can see 3x and 12 can both be divided by 3, and that happens in both binomials. That's because there's a GCF of 9, which is two 3's. One happened to be put into one binomial, one into the other. And so if either of the binomials or both binomials have a common factor after doing this, you miss the GCF somewhere. So you could go ahead and factor out the GCFs now. Maybe I want to factor a 3 out, right? And then I factor a 3 out. And then you would just multiply those two together. and put them out front and write your two binomials. Or what you should have done, and really the proper way of doing this, would have been to factor the 9 out in the beginning. So that would have given you x squared minus 16. And then you get the 9. Square root of x squared is x. Square root of 16 is 4. 1 with a plus, 1 with a minus. And you would have gotten the same answer. And so that's just something to be aware of.